Hey everyone, I'm Jay and welcome to Python Lab 5.10, the 10th in this series, right? In this one, we are going to use a loop and we're going to apply, or we're going to use a counter in that loop, all right? Counters are very useful to count how many times the loop goes through, and also the variable that we use as a counter, we can use that variable from within the loop in order to use that number. Oftentimes that number is very important to us. For example, if we're looping through an array of items, or in Python we may have a list of items or something, the counter variable will be a direct reference to which element along that array we are currently accessing, right? And then, of course, depending on your loop, depending on what you're doing, you may have the counter -1 being equal to the previous element, or the counter +1 being equal to the next element in the array, so that you could access uh, the current element, but you can also easily access the next and previous element as well, right? There's plenty more you could probably do with a counter. Those are some simple suggestions to have a look at. So in this lab, we're going to start off, of course, we're going to create a file. We're going to put our standard comments at the top, and we're going to describe what we're doing in that file. And then we're going to go ahead and get to work. We're going to create a loop that will continuously run as long as the user keeps inputting Y or yes. Okay. So if you look back at our previous lab when we introduced while loops, we had a few different conditions. We had a positive condition and a negative condition, and then we also had a positive and a negative condition with a loop control variable. So in the second one with the control variable, instead of testing directly what the user input, we tested and verified the user input and got either a true or a false value from that. That's the loop that I recommend you use for this, is the positive condition with a control variable for this one, right? So as long as the user continuously gives us the positive condition, the condition that yes, go ahead and keep looping, that's the Y input, then we'll keep looping. But we're not going to use that Y directly in the loop control. We're going to test within the loop. And in a minute, when we look at the code, you'll see why that's important compared to the other way. Right? This is going to make it a little bit easier for you. So we're going to use that loop, all right, with a positive condition as opposed to the negative condition. If you remember from last time, the negative condition is the user will tell us when to stop. In the positive condition, the user tells us each time to keep going. Okay, so very, very similar, but decidedly different. Okay, within the loop, each time the loop runs, each time it cycles, right, we're going to increment that counter, and you're going to figure out what value you need to prime it to. And if you code yours exactly like mine, you'll see what to prime it to. If you code yours differently than mine, you may or may not need to prime your counter to a different starting value. Okay, that's what the priming is. We're going to give it an initial value. Okay, so you're going to give it that value, and you're going to figure out what the correct value is for your program. Each loop cycle, we're going to output the value of a counter. So we're going to ask the user for input, and then we're going to output the value of the counter. Hopefully, we're going to output according to the condition of the input, right? That's why I would suggest you use the loop with a control condition rather than just going with the user input straight away. Okay. And then at the last loop cycle, we still want to output the final value of that counter as well. And some things to be aware of when we're outputting that final value or any of the values. I want you to make sure that your output value actually does output the exact correct number of times the user has given us a Y, the positive condition. And on the last one, depending on how you write your code, The last one may or may not output incorrectly, okay, depending on how you write it. Now, mine, it's correct, but I'll show you some things that might happen, okay, that could be incorrect. You could count, depending on when you do your final output, you could also have a double output at the end. We don't want that. We don't want a double output, okay? So those are some things to be aware of. And then that's going to take care of that loop. And when you finish, I want you to write 2 more loops, much simpler. Probably should rearrange these. I think I'm going to rearrange these in the assignment so you can do the easy ones first. You're going to create a loop that counts up from 1 to 10 and create another loop that counts down from 10 to 1. Right? You might be thinking, how do I make it count down? Well, as easy as you can add, you can also subtract, correct? Not that hard. And for those of you who want a little extra challenge, you get some extra points. I'm not going to show you how to do it in this video, but if you put each of your loops inside of a function and then you call that function from your main program, I will give you some extra points. All right. If you're having trouble with that, just skip it and do the main part of the assignment and get your proper credit for that. All right. Here's a little example of what the output might look like. In the first case, I've asked the user to input a Y to continue or N for no. I said no right away. And I got, my format's not working correctly. I will fix that. And then we'll get on that. But my number is outputting correct. Weird. Oh, I see why. I have an improper character there. That's okay. And then on the next one, I've done Y 1 time, output of 1, and the next time I did something other than Y, didn't have to be N, remember we're only testing for a positive condition, and then I've output a 1 again with a slightly different message this time, okay? So let's have a look at the code, and I'm going to fix my output so I don't get this 3D in there, and then I'll fix the assignment here. Let's jump into that. Here we are, and today I'm using VS Code to run my code, and I'll show you some cool tricks that we can do in there. When I run, this is running in debug mode, which is primarily what you will get. At the end, you'll see your output down the bottom, but you also have, because it's debug mode, you can see all your variables, and I've put in a breakpoint at the end. Any line of code could be a breakpoint. Okay, I'm just making a variable called breakpoint, setting it to 0. It's a useless variable. I just need a line of code to be my breakpoint, so that's what I've chosen to do. I could have actually done this one as well. Okay, and you just kind of click over here, it makes this little red mark, and you get a breakpoint. And this one is highlighted because that's where I've currently stopped. You can put as many breakpoints as you want in the code. What the breakpoint does when you're debugging your code is it will pause execution at that point, and then over here you have the ability to see what all the variables are equal to at that current moment in your program. So especially useful when you're doing loops and you may have a bug and you're like, oh, well, what is the value of all these things in my loop, so I can try and track down my bug in the middle of a loop process. You put a breakpoint inside the loop, and then every time the loop executes, it will pause, and you get to see those values. And then you can press the play button to continue, and it'll go through the loop again and hit that breakpoint again, and pause, and you can see all the values again. So that's pretty useful. That's why I'm using VS Code for this rather than Thonny, which I had been using previously. I specifically wanted to show you that. But this ran all the way to the end, and we can see my outputs here. I did not go through the loop even one. Well, I went through one time. I said no or T, whatever, or 0 times. Let me fix this output. I need to put a little point instead of a comma. That should fix that for me. But let's go through this one line at a time. So I have my standard intro, like I should, my descriptive comment. my shebang telling me I'm using Python 3, just in case it runs on a computer that doesn't have Python 3. And then I first have my loop, my big loop with the control value and a counter. The counter is the big point on here that we're trying to get across in this lab. So I have a variable for my user input. It's preset, it's primed to a y value, okay? Although it doesn't necessarily need to be this time, which we'll see in a moment, right? And then I have my loop control. This is important for this loop is I primed it to a true value so that the loop will execute at least once, okay? And then I've primed my counter to start at a value of 0. So the loop starts, loop control is equal to true, and we jump into the loop because it's true. Right? So the first thing we're going to do is get some user input. Please input a y to continue looping or an n to stop. And we're not checking for n, we're only checking for y. We could check for both. We could do some sort of bug error checking or whatnot, some to really prevent the user from putting anything other than a y or an n, but it's not that sophisticated of code. We don't care. We just want the y's. Okay, so we're checking if the user input a y or an uppercase y, lowercase or uppercase, in case they get that caps lock button selected. Right? If the user has selected this is the positive input condition, we're going to go ahead and increment that counter plus equals 1, which means that we're going to take 1 and we're going to add it to whatever the current value of counter is. So every time the loop cycles, when it gets to the end of the loop, it's going to cycle over again, test the loop control every time, make its way down to this line of code again, maybe, right? We do have an if statement, so it might not get to this line of code, but every time it does, it's going to take whatever the current value of counter is. And in this case, it's currently set to 0 because I never did hit y one time on this run, okay? It's going to add 1 to it. So this line hasn't executed this time because I never input y. Assuming the user did input y, we're going to increment the counter 1 time, and then we're going to output our message to say the loop has run some number of times so far, and that number is going to be the value of counter. So if we had a starting value of 0, we input y once, we'll add 1 to the counter, now it's equal to 1, and we'll output the loop ran 1 time so far. If the user inputs anything other than y, we fall into the else clause. This is a negative input condition, or not a positive input condition, actually. Not a positive input condition because we're not actually testing specifically for the negative condition. We're only testing for the positive, and this is else, right? So we're going to trigger the loop to fail. Now they did not input a y. We're going to say loop control is equal to false. And then we're going to output the total number of times the loop ran here. Okay, some options for you is you might print this output not within the loop, but you might want to print it at the very end of the loop. You can totally do that. In fact, it won't change my code at all. Okay, it won't change the execution of it. The only difference will be that this print statement happens after the loop rather than from within the loop. Okay, I chose to put it within the loop because I like to keep things kind of balanced. I have one positive print statement and one negative print statement. But you could definitely put your print statement on the outside, right? And you could use your loop without this control variable here and just test for the y, but you are going to have to do some sort of an if statement at the end anyway to make sure, or within the loop, to make sure that you don't double print either of these. You don't want to print both of them on the same run through. So I have chosen to put them here and balance them out, right? Because if you do print on the last loop, if I print that the loop has ran 4 times so far, and then at the end of the loop, when it exits, I say loop ran 4 times in total. I don't want to double that up. My instructions specifically say don't double that up. All right. So this loop has completed. I'm printing a blank line just to put some space in here, right, in my output. And then I have two different examples of how to just do a very simple counter. The first one, easiest one in Python, is a for loop for I. Now I is a made up variable that I'm using as the incrementer, as the counter for this loop specifically, for I and range from 1 to 11. Now the way range works, it's got some options on what you can input. I could just do range of 10. It will give me 10, but it will count 10 actually from 0 to 9. It's very useful for arrays, but I want my output to count 1 to 10, not 0 to 9. And so if I did a range of 10, I could print I plus 1 every time. Definitely an option. However, we're going to be adding 1 every single time. And if this were a large amount of code, it would eventually begin to slow things down, especially if this was a habit of mine to do all the time in my code. That's a bad habit to have. So instead, I'm going to set the range to be exactly where I need it to be. It's quite useful to make sure that your numbers are exactly their value and then you don't have to do math every time. Even if that's simple math, it can add up in large programs. So this is going to count from 1 to 11. When it gets to 11, it's not going to do the 11th one. That's the stop condition, and it won't do it. Okay, and it's just going to print I every time. You can see in my output here that it is just printing 1 through 10, and then I have another blank line after that. So this is really simple. I could have some more code in here. If I wanted, I could put more code in there. Right? More code here too, if I wanted. All right, if I wanted more stuff in the for loop, I could put more stuff in there. But let's move on to the next. How am I supposed to do a countdown, right? The for loop counts up automatically. It starts at the first number and goes to the second number. You could actually use range to make it count down, but I want to do a while loop and I want to control that variable myself specifically. That's kind of what this lab is all about, right? So I start my countdown, set it equal to 10. My while condition is while the value of countdown is anything larger than 0, we're going to continue. So I'm going to print the countdown value. Remember, it starts at 10. So the first time it will print 10. Then I'm going to subtract countdown minus equals 1 and subtract 1 every time. So we'll go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We'll do that last one. And you can see our output here. It should not. VS Code does have a problem with scrolling the output, but I have 10 and it did stop at 1. It won't go to 0 because the while condition will break at a value of 0 or less. And it's not going to do what's inside. So once the value is 0, the loop stops and does not execute further. Print one more blank line, and then comes my breakpoint. So let's run this again. Continue. Oh, it's finished. Let's run and debug one more time. Here we go. Gotta scroll for my output. Please input a Y to continue looping or an N to stop. I'm going to do a Y a couple of times this time. Okay, loop ran 1 time so far. Loop ran 2 times so far. Loop ran 3 times so far, and an N and a lot of output. Loop ran 3 times in total. Okay. So it does not count that last one because I told it to stop. strictly speaking, the loop itself is actually running 4 times, but the user, from the user's point of view, they said no, and so we're going to pretend that it didn't run that last time, because that would really be confusing to the user, right? I could change the language and say, instead of loop ran, I could say you said yes this many times, and that would be accurate for both parties. Also, you may notice there's a little bit of weird spacing here. See, I put in a 3-digit number to output. So in case you wanted to run this 100 or more times, the spacing would remain the same until you ran it 1,000 times. But once you do select anything other than Y, we get our count up from 1 to 10 with our very simple code here. And then we get our count down from 10 to 1 with our still fairly simple but a little bit more complicated code right here. All right, so I'm going to modify the assignment to put the easy ones first and then the hard one last. But that is lab 5.10 or module 5 lab 10. All right, thanks for watching, and I'll see you next time.